This is Techtastic.
Scientific endeavors. This project is said to usher in a new era of astronomical research and discovery that promises to change how we view the universe. It is today's big thing for astronomy. It's a very large and expensive technology that will help us better understand galaxies in our universe. It's expected to be the first in a series of 4 telescopes that will be built to try and understand the cosmos. It can detect light from the entire history of the universe and will be able to see farther than any other telescope. It is the successor of the Hubble Space Telescope, and it takes the gold for the most powerful telescope ever built, so far, according to NASA. With everything aforementioned, has the James Webb Space Telescope lived up to the expectations? Did it deliver the highly anticipated outputs? And how is it doing now months after it was released? It's time for you to stick around and find out. Welcome back to Techtastic. You know the drill, slam that like button and make sure you are subscribed. On December 25, 2021, NASA and its partners celebrated the successful start of a $10 billion mission. NASA Administrator Bill Nelson referred to the successful launch of the James Webb Space Telescope as a wonderful day for Earth. Since the James Webb Space Telescope will be able to see further into the universe than any other telescope before it, it will be able to observe planets that are too small to be seen by telescopes on Earth. This will give us a lot of information about these planets and help us to understand how they're formed. The James Webb Space Telescope will also be able to look at the atmospheres of planets and gas giants, capacitating various more studies. With these amazing features, the only question left was, when can we see it happen? The James Webb Space Telescope, operated by NASA, arrived at its permanent location in orbit on February 9, 2022, and began preparing to view the cosmos. However, it must continue to be extremely cold to do this. Webb studies infrared light, often known as heat. Therefore, the telescope must remain extremely cold to ensure that observations aren't impacted by any additional temperature. So, the mission crew painted Webb's radiator, which helps to dissipate heat from the telescope, and other components an ultra-black color to keep it cool enough. Literally. Remember this detail, as it will be part of one of the milestones of this billion-dollar project. On February 11, 2022, Webb's first photograph was finally made public by NASA, as scientists continue to strive to align the mirror to produce a single, ultra-crisp vision of the universe. The picture shows a star called HD 84406, as seen through each of the observatory's 18 golden mirror pieces. A bright spot like HD 84406 offers a useful goal by which the team can align JWST's honeycomb-shaped mirrors and begin capturing engineering data. This star will be crucial for this particular objective, but once the observatory starts its science projects, it won't be examined. HD 84406 will be too bright to study with Webb once the telescope begins to focus. But for now, it is the perfect target to begin our search for photons, a search that will lead us to the distant universe, writes Jonathan Gardner, Webb Deputy Senior Project Scientist from NASA's Goddard Space Flight Center, and Alexandra Lockwood, Project Scientist for Webb Science Communication. 10 days later, on February 19th, the next image from NASA's brand new James Webb Space Telescope revealed a star twisted over 18 separate photographs due to discrepancies in mirror alignment. A week later, a fresh photograph shows the same star 18 times, but the dazzle has formed a sort of cosmic snowflake as the observatory's image has sharpened. What appears to be a basic snapshot of fuzzy starlight is being used to align and focus the telescope, allowing Webb to provide unprecedented views of the universe. The team will gradually modify the mirror segments over the next month or two until the 18 pictures merge into a single star. Then, on April 1st, NASA reported that the James Webb Space Telescope is only one step away from completing its 7-phase alignment process. The next step necessitates further cooling of the observatory's most heat-sensitive device, the Mid-Infrared Instrument, or MIRI. Finally, on April 14th, the Mid-Infrared Instrument, or MIRI, on the James Webb Space Telescope reached the super cold temperature required for proper operation. Because the sensor is designed to detect infrared light, which manifests as heat, the temperature must be kept below 7 degrees Kelvin, which is comparable to minus 447 degrees Fahrenheit, or minus 266 degrees Celsius. According to NASA, the milestone has been accomplished following a rigorous and meticulous cooling process. And on April 28th, the 3-month procedure of aligning the instruments and the mirrors of the James Webb Space Telescope was finally finished. It finally became cool enough. The whole adventure did not come without challenges, however. Micrometeoroid strikes are an unavoidable component of operating any spacecraft, which frequently sustains several impacts throughout extended and fruitful science missions in space. Between May 23 and 25, NASA's James Webb Space Telescope was hit on one of its primary mirror segments. Despite a slightly noticeable effect in the data, the researchers discovered that the telescope is still working at a level that exceeds all mission criteria. Extensive analysis and measurements are ongoing. Impacts will continue to occur during Webb's existence in space. Such events were anticipated when developing and testing the mirror on the ground. Webb's first-year performance is still considerably above expectations. The observatory is still fully capable of completing the work it was planned to do. Alas, with all the hard work, painstaking operation, and numerous obstacles, the James Webb Space Telescope came to full fruition as it delivers the image dubbed Webb's first deep field. It depicts an incredibly clear, ultra-deep perspective of the universe, catching a galaxy cluster known as SMACS 0723 as it existed 4.6 billion years ago. On Monday, July 11th, President Joe Biden, Vice President Kamala Harris, and NASA Administrator Bill Nelson released the first scientific quality image taken by the $10 billion James Webb Space Telescope at the White House. According to NASA, the image is the deepest infrared vision of the universe yet, and it was created with only 12.5 hours of observing time on one of the telescope's 4 sensors, and this was only part of the beginning. The space agency has previously hinted at which celestial objects space lovers might expect to see in these photographs. The agency revealed on July 8 that the revelation will include views of the Carina and Southern Ring nebulas, as well as Stephan's quintet of closely packed galaxies. And on July 12th, NASA released a spectacular image of the Carina Nebula. The Carina Nebula is a vast cloud of dust and gas located approximately 7,500 light-years from Earth, where stars develop and die. JWST's view of the nebula, which blends near-infrared and mid-infrared light, provides a whole new perspective on its activity. This reveal is accompanied by the 5 galaxies of Stephan's quintet. Stephan's quintet, located in the northern constellation Pegasus, is made up of 4 galaxies that are tightly connected, cosmically speaking, roughly 290 million light-years away. A foreground galaxy hides on the left of the image, around 40 million light-years from Earth, in a cosmic alignment chance. The latest image Webb produced depicted Jupiter in a clear, high-resolution photo. The images are extremely precise, capturing the massive planet's cloud bands, the renowned Great Red Spot, and even some of its weak rings. Several moons are also visible in the photos, including Europa, a freezing world with a massive ocean beneath its icy shell. With all of these groundbreaking cosmic achievements, who knows what Webb would bring in the future? Webb was meant to examine the first stars and galaxies to emerge in the universe. However, the Infrared Observatory is a versatile tool that astronomers will employ to